Hi there, I'm Jenna Morris, a PhD student at the University of Washington. I'm excited to share some highlights of my poster, which presents initial insights from my dissertation work, looking at the carbon consequences and reburn potential following fires in forests west of the Cascade Mountains in Washington and Oregon, or Western Cascadia. I also encourage you to check out posters of my lab mates, Madison Laughlin and Liliana Rangel-Parra, for additional dimensions of fire in Western Cascadia. Diving into some poster highlights. We know that increasing fire activity is raising concerns about forest dynamics. However, critical insights are missing on fire effects in systems where wildfire is infrequent, particularly effects on carbon dynamics and reburn potential. Western Cascadia forests are characterized by large, infrequent standard-placing fires and are among the most carbon-dense forests in the world. Historical evidence also suggests that these forests have a tendency to reburn multiple times in the decades following an initial burn. Recent fires have burned 500,000 hectares in this region, creating a really unique opportunity to fill this knowledge gap. Specifically, we asked how post-fire above-ground woody carbon storage and fuel profiles are affected by pre-fire stand age and burn severity. We can imagine that the effects of fire in these forests may differ greatly based on the structures present at time of fire and the severity of fire experienced, with implications for post-fire carbon trajectories and reburn potential. To answer this question, we measured above-ground woody biomass, surface, and canopy fuels in 1 hectare plots distributed across recent fires. Plots were stratified by pre-fire stand age and burn severity. In my poster, I focus on results from the 2017 North Peak fire. Preliminary results suggest that above-ground woody carbon storage and both surface and canopy fuel loads increase with pre-fire stand age. This is likely due to older stands having more biomass at time of fire. Total and live biomass decreased with burn severity, while dead biomass increased due to greater combustion of material in heavily burned stands. Ultimately, these findings highlight the dominance of pre-fire stand structure on controlling the outcomes of infrequent high-severity fire in Western Cascadia forests. The photos below help illustrate this, showing just how different the effects of high-severity fire can be across stands of different ages. These findings have important implications for forest management, especially in the face of increasing fire activity. Future work will help to build critical understanding of forest responses to infrequent, severe fire over time and under changing climate conditions, so stay tuned. Thank you for stopping by my poster and hope you're enjoying the conference.